Making P2nP is illegal, so if you do it at your own risk. This is John Black, and this is part 2. Remember, I did say this is a dehydration reaction. So let's say you wanted to make the phenyl nitropropene. You would take benzaldehyde, which is a liquid. You would take nitroethane, which is a liquid. Your primary amine. Normally you want something like butylamine, although any primary amine will work. Your solvent, you just mix them all together and you'll make your beta nitro alcohol here. If you want to dehydrate it, you're going to have to heat it up a little bit, and you will have an equilibrium between all these products and reagents and stuff. And it will only make so much. If you want to make more, you got to take the water out. How can you do that? Well, there's a technique with a Dean-Stark apparatus, and it's based on this one thing. If you distill a pure hydrocarbon that has a little bit of water in it, right? It's dissolved in it. So distill it, right? The hydrocarbon will carry some of the water with it, right, as an azeotrope. And when it condenses, instead of it the water dissolving back into the hydrocarbon, it forms two different layers, okay? And that way you can get the water out because it's in a different layer. Now, if you want to use a Dean-Stark apparatus, the hydrocarbon must be less dense than the water. Okay, now there is another way you can do this, but this type of Dean-Stark apparatus I'm going to show, the hydrocarbon has to be less dense so that it floats on top of the water. It also has to have a high enough boiling point to reflux, although most types does. Benzaldehyde has a high boiling point, and so does nitroethane. So no matter what solvent you have, it's probably going to be good to boil it high enough. You figure nitroethane boils at what, 112, something like that. See, 115. So you're going to want it to be lower. You want the azeotrope to be lower than that. You want it to be lower than both of your reagents, but you don't want it so low that you're not refluxing at a hot temperature. You know what I mean? You want it between, say, 70°C and 90°C, the azeotrope boiling point. Make sure that, if it's a solid, like, if you use vanillin or something, if it's a solid, you got to make sure everything's nice and dissolved, right? Put it all together, and then you put your amine in, and you start making your beta nitro alcohol, and then you start refluxing it. But look at how I'm going to show you to reflux it. And also, here's another thing too. You also have to have the catalyst must have a high boiling point too, because otherwise you'll be distilling it out of the pot too fast. You know what I mean? Like if you have methylamine, you really couldn't probably do that with a Dean-Stark. I don't know, maybe you can, but I think it would be too low of a boiling point where you would be boiling out your catalyst too fast. You know what I mean? For this to work properly. So you must have a high boiling point or a higher boiling point primary amine. And you can see if you use a low boiling amine, all your amine is going to be distilled over. You won't have any in the top because you're just using a small catalytic amount. So you want it to be whatever the azeotrope boiling point is for this, let's say toluene in water or benzene in water, whatever that azeotrope boiling point temperature is, it would be best to have your primary amine have a higher boiling point than that. That way when it distills over, the amine stays in the pot. Or close to the, you don't want it to be a lot lower, that's for sure. You'll be distilling out, you'll have to, and you could, even if you use methylamine, you could do it that way, just add a whole bunch of extra, methylamine. And this is the setup right here, okay? Now normally you put your heat here, this is your pot that you have your product. Okay, normally you have your stuff in here, you boil it, and vaporize, come up here, and this water-cooled condenser will cool it all down, and the liquid would drip into this receiving flask. This is a Dean-Stark apparatus, okay? When you distill it, the vapors come up, they go through the condenser, just like over here, but the condenser is up and down instead of slanted. So all the stuff drains, when it condenses, drains down into this little thing here. Sometimes there's a valve here so you can open it up and pull it out. But if you can think of a separatory funnel or a sep funnel, what's going to happen is the water is going to collect right at the bottom. This is going to keep filling up, filling up, filling up with the hydrocarbon. Let's use a hydrocarbon. Let's say toluene or benzene. Okay, toluene or benzene, and it keeps dripping down. Like I said, it forms an azeotrope. When it condenses, they separate out the two layers. The water, you'll see the water will, as a drip comes down, you'll see the water will go straight through the hydrocarbon. That's how you'll know when you're done, because when it drips, you won't see any water going down to the bottom. Also, you'll see a drastic it'll slow down on water production. But anyways, as it fills up, look what happens when it gets to that point. Now the droplet condenses, drops into this vat, the water sinks to the bottom, right, and fills up this bottom part. But this overflows this is all your toluene or your benzene. It overflows back into the pot, right? So you just keep refluxing, keep refluxing. How do you know when you're done? When it stops making water, you know? Now you can figure it out beforehand, you know, if you know that you're going to make a half a mole of water or a quarter mole of water or whatever, you can figure it out, you know, 18 milliliters is a molar volume of water, so a half of a mole, that would be 9 milliliters. You know, a tenth would be 1.8 milliliters. But you get what I'm saying? We'll figure it out, and then usually these have little lines on it, so it'll tell you how much is there. And that is the best way to do the reaction, is to do it this way. That way you get the water out. I don't know if you can just, maybe you can even just put molecular sieves in there. I don't know. I don't know if they can stand the heat or whatever, or the chemicals, but could maybe, I don't know. This is definite. You might be able to just throw some molecular sieves into your reaction. As you reflux it, molecular sieves will soak up the water. The reason I don't use molecular sieves, which you need 3A molecular sieves, is because you need so much of them. You know what I mean? I don't really have high purity molecular sieves. I get them off eBay. So I have to add even more than that. And it just takes up so much volume. I don't know. I don't like using them. Okay, here's the Dean Stark apparatus like we had in the first example. Second example is the way ChemPlayer does it. Keep in mind, he does not use these same chemicals. He uses vanillin as his aldehyde and nitromethane as his nitroalkane. So he makes a totally different thing. He does not make P2nP, but it's the same reaction. It's a Henry reaction where he's dehydrating the product. So basically, he puts all his stuff in here. He uses ethanol as a solvent because he doesn't care. You know, like if you use ethanol, you can't use ethanol in a Dean Stark because the azeotrope won't separate. It'll just form one layer. But he's not doing that. And I'm guessing the reason why is because he's using methylamine. Methylamine has such a low boiling point that you would be boiling out the methylamine constantly. I mean, you have to either dump in a bunch of methylamine in the first place or keep adding it constantly. I don't think it would be viable. So that's it. Just add your two reagents, your primary amine and your solvent. Reflux it 3 hours, you know what I mean? And you're done. But keep in mind, in that last method, you're not taking the water out. So you can only make so much before the equilibrium stops production of your product. Now this is the last way. If you don't have a Dean Stark apparatus or you cannot make one, you can always just set it up like a regular distillation. The receiving flask, you'd use a test tube. And you can buy test tubes that have ground glass joints. Or a very small sep funnel, you know what I mean? And they sell like 25 milliliter sep funnels, 50 milliliters, you know what I mean? That have ground glass. You can just connect it there. And that would be your receiving flask. As you reflux it, you'd use a Vigrex column over here. As you reflux it, it's getting distilled out, just like up here. just like up here, it gets distilled out, but instead of going into this vat where it can fill up and just automatically go back in, now it's distilling into this test tube with this sep funnel, right? And you'll see the water will still separate out on the bottom. And when the test tube gets filled, you'd have to wait, turn the heat off, so you ain't getting fumes coming out of here. Pull out the thermometer and put a funnel in there, and take the test tube and dump the test tube in everything except the water. You don't have to be perfect about it, because you're going to be doing that a lot. This just takes a while to do it, you know what I mean? You're going to be dumping that test tube 100 million times. That's why Dean Stark is great. Then reattach the thermometer after you pour it in, and put your water back over here with your toluene, the benzene, whatever you're using, right? And then go back to distillation. You distill some more, it takes the water out, and fills up the test tube. Then you have to repeat the process. Turn the heat off, wait for the fumes to subside, take the thermometer off, put a funnel in there, and dump your test tube into not all of it, just the top layer, and then close everything back up, put your test tube back over here, your set funnel or whatever, and start your distillation again. That way you can remove the water. You might not want to do this for full term, but making the water production, the first hour, say, you're going to make a lot of water. After that, the water production may be so slow that it might get on your nerves having to redump the toluene back in there for the little bit of water that it produces. Now for this method, you couldn't use ethanol. You'd have to use some type of hydrocarbon like toluene or benzene, and you would want whatever the boiling point of that azeotrope of those two were, you would want your primary amine, to be higher than that. Okay. If it's not, you're going to be distilling it out. Although in this type of method, you're going to be dumping it back in all the time, so it might not matter. But I'm just saying, keep that in mind. And that's basically all the methods or whatever. If you want to know how you purify it and get it out of there, I'll leave a link to ChemPlayer's video. Like I said, he's not making the same thing, but it's basically the same process, and you can see how he does it and how he extracts his stuff out and purifies it and whatnot. How to make a high boiling amine. You can go to any GNC or health food store or whatever. They usually have amino acids. Here's 2 of them. You can see if you do a soda lime decarboxylation, you can make the amine. You can decarboxylate, get this carboxy group off of there, and what are you left with? You're left with amines. So they're both a form of butylamines, which is a great catalyst for this reaction, this butylamine. So these are very close. They have nice boiling points that are high. They're probably about 98, somewhere around there. They're lower than the reactants boiling points, but it's higher than the azeotrope of your solvent and your water. That azeotrope boiling point is lower than this, so this will not distill over with that azeotrope. So you only need a little bit of this as a catalyst, so you could actually even make it in just a test tube. Put all your stuff in here, heat it up, right? You got a tube going into this HCl. The reason why you boil it into HCl or distill it into HCl solution is because the amine is going to stink to high heavens. If you distill it and it goes into the HCl, it will make an ammonium salt of the amine, which does not stink. Then when you want to use your amine, right, you take off the lid, here it is right here, you throw in some sodium hydroxide so that it freebases it back into the amine, and then you throw in whatever your solvent is. If your solvent's toluene, use toluene. If your solvent's benzene, use benzene. Throw it in there, soak up your amine, use a set funnel to get it out, or a pipette. Get everything out except for the water, and put it into your reaction. Anyway, you all have a great day, and always remember, science is great.